Assalamu alaikum everyone. So today we'll be dealing with searching and sorting. And before we go to this searching and sorting, let's have a little discussion about the 220 syllabus. So basically, the things that are about to come will have codes. So you will have codes from arrays and linked list, and there are different kinds of arrays. There is linear, there is circular, and there are three types of linked list. It could be dummy headed, it could be circular, it could be linear, and it could be a fusion of these two or a fusion of these two, and there could be more. So these are two topics from where you will definitely have codes, and then there will be sorting. There is a high possibility of getting codes from sorting, which would be this or maybe this, and there would be recursion. It doesn't make any sense. It looks like I'm just writing something, a wave of a sea or something. Anyways, there could be recursion. These are the topics that will include codes, and maybe there would be a code from stack or queue, just one or two, maybe. That's a possibility. So these are the points where we need to focus on the coding. However, including all of these plus these and many other topics like graphs, trees, graphs, all of these require understanding. Let me give you a new color. Understanding, which is crucial for you to do something, and you also need this for your next course, 221 algorithms. Understanding, that's very crucial over here. So let's go to binary searching and sorting. If you are confused about what on earth is this is actually the all nodes you will find on your TSR. If you don't have it on the TSR, you should have it. If you don't, you can just click on the link below and get the virtual TSR I provided. So let's get started with searching and sorting, inshallah. So okay, we need to remove this. And first, there are two types of searching. Now I don't have to define what searching is, right? Searching means you have this array, or maybe you have this linked list, and you're gonna search for an item. So you have 1 to 100 items on an array, and you're gonna search for, maybe it's a list of students, and you're gonna search for, let's pick a common name. Okay, how about Saqib? You don't actually have to search it. You just put a random number twice or thrice and you will find a Saqib. So let's not do that. Let's find something we need to search. How about a unique name? Maybe, oh, let's just use maybe. I'm kidding, right? I'm just kidding, just to mess up with you guys. Maybe, I don't know what this is, but consider this, let this be B. So you need to search for maybe among this hundreds of words or names. So there are two ways to do this search, sequential and binary, and this can be the same thing for linked list. Maybe there's a list of students and we're gonna search for this Hebrew word among this list. So how do we do this? First, we need to understand what are those two types of searchings, why are they named that way, and what are their uses, and what are the advantages and disadvantages, which is actually a part of algorithm, but we'll learn it. So sequential searching. Before we go to the code, let's understand what this is. Sequential is as it sounds. So you have this, you will search through the array and list sequentially. So you will go from 1 to 2 to 3 and so on. You will go on until you reach 100. You'll keep searching. That's sequential searching. Simple as that. How do we do that? So there are some advantages when we have sequential searching. First thing is, it does not require that the container support random access. That means you can search linked list as well. So linked list doesn't support random access. By random access we mean, okay, I can go to index number, if I write a index 10, I can go to index number 10 with just this one code, but I cannot go to the 10th head of a linked list anyway. I have to go node.next. Pardon the handwriting, really forgive him, really forgive the handwriting. I just imagine that this is node.next. So you will have to reach node.next by doing this 10 times, unlike an array where you can just write the index number. So this is called random access. So this is the advantage of sequential sort, and it does not require the data to be sorted. So that's another advantage. So two advantages: it does not need random access and it doesn't have to be sorted. So if there is another thing, another kind of search, probably that requires random access and being sorted. So we'll get to that. Let's just deal with this first. Okay, so here we have the code. Let's look at a decent and friendly version of this. I have this over here. So here are the list of array list, random, and these are some letters I randomly put. Of course they don't make any sense and they're obviously not any humans. So we're doing sequential search over here. So you'll take an array and you will take the size of that array, and you will, of the key means the item you're looking for. So we'll run a for loop that will start from 0. Since this is sequential, it should start from 0. It will go until it reaches the size. This will be the size you provide, and if it's an array, you can just put that data length over here, and I++ the increment, and if it equals to the data, and then return the index number that you have reached, and if not, then just return -1. That means that's one way of saying sorry, that item was not found. You can just return anything over here. So that was sequential search. Simple as that. And you can also do it for the list. So you do the same thing. You take a node head and you take the key. There's no size over here, so we won't include that. You take node head, you start from int I equal to 0, and then you also keep an n not equal to null and increment it, and both ways. So, and then if you find that, return I, because you have this over here, and if you don't, this is just similar to the thing of finding the index we did on linked list. So it's nothing new to you. So this is how you do sequential search. Very easy, right? Very easy. Now let's make things complicated. Binary search. Okay, so what's binary search? Do I have to transform my code into binary 01011101? Okay, CSC 260 time or 230 time? No. Thank anyone that you don't have to do that. It's nothing like that. Binary search is actually a kind of search. So if you have an array of 20, this search suggests that first look at the index number 10, which is n by 2 equal to mid. I know the word mid is very dangerous and all of us don't like this word, but this is just a middle. This stands for middle, okay? So this 10, we will look at index num 10. If we find that key over here, then we return it. If we don't, then there are two possibilities. The key will be from 11 to 20, or the key could be from 0 to 9. There are two possibilities. So which one should I do? If it's an integer, I will just compare. If, for example, we are searching for 30 and the array is something like it increases by 2 or 5, maybe, I don't know. You have 5, 10, 20, this is 20, this is supposed to be 20, and you have 40, 50, 60. So you're searching for 50, right? So the middle of this is 30, which is n by 2, as I mentioned over here. If 30 is not the item I'm looking for, then I will look here and here. If the number I'm looking for is bigger than 30, then I should look on this side. There's no point in looking on this side, because this side doesn't have a number bigger than 30, and that is why a binary must always be sorted. You need to have a sorted array for this, and it also requires random access. That means you cannot do binary search on linked lists. Okay, that's the idea. So you're pretty sure that if the number is greater than 30, since my array is sorted, I don't have to look on this side because it has smaller numbers. I will have to look on this side, and the vice versa. If you find that the number you're looking for is actually smaller than 30, then there's no point on looking on the right side. It's better to look on this side because you're sure that the lower numbers are over here. That's binary search, as simple as that. And the code is also simple, depends on what you're doing. This is a code that is used for any kind of data type. The easiest one is for integers. Like I just mentioned, you just compare the numbers and then you can see a decent version of this. So here you have, I'm bored with this red color, let's try something new. Okay, I don't know if this is even a color. So you take the starting value and the ending value, and this is the mid I was talking about, which is obviously the start plus 2 or last divided by 2. If you find it on the mid, then return that item, return that index. If you don't, then just compare with string compare. If you find it greater than 0, then it is obviously on the right. If it's less than 0, then it's on the left. And for integers it's even easier. This is very easy, guys, and probably won't be getting coding about search, so I'm not focusing much on that, but you just need to know how it's done. That's all. Okay, so there's a fact of time, and you can see that the worst case performance time of two of them are different. So the worst time case, your faculty might talk about this. The worst final case could be n in case of sequential and log 2n in case of binary. So binary is kinda faster because you're straightforward. If you don't find it in the mid, go on the right. If you don't find it in the right, go on the left. So you have a very good sequence, but in sequence you'll have to go from 1 to 100. And there is a possibility that the number you're looking for is actually the 100th one. So you have to go to 100 times, but that's not the case in binary. If it was binary, he would first look at 50, and if it's greater than 50, then he will look after 50, and if it's less, then he would look before 50. He would never have to do it n times. So that's the advantage of binary search. Then again, for the binary search to work, you need a sorted and random access system. So those two are important too. So folks, I know this could be the shortest video I have ever released on CSE 220 except the introduction, but we are done with sorting. That's all. Sorry, searching. We'll have a separate video on sorting, and that's all for searching. Thank you for watching. Keep surviving, guys.